Welcome to Water Science for Everyone.
Imagine digging a hole in the ground. For a while, the soil feels dry, then damp, and eventually, you hit water. That point where water begins to fill your hole is a fascinating and crucial concept in hydrology. To directly answer, yes, the water table is indeed defined as the top surface of the saturated zone in an unconfined aquifer. This boundary is a critical reference point for understanding groundwater systems. The saturated zone, also known as the phreatic zone, is where all the voids and pore spaces in the geological material, like soil or rock, are completely filled with water. This water is under positive hydrostatic pressure, meaning it is pushing outwards. Above this, we have the unsaturated zone or vadose zone, where the pore spaces contain both air and water. Here, water is held by capillary forces and is under negative pressure, effectively being pulled downwards. The water table marks the precise level where the pore water pressure is equal to atmospheric pressure, serving as the transition between these two distinct zones. Visualizing this is key. Think of a sponge. When it is completely soaked and dripping, its internal pores are full. That is the saturated zone. The level at which water no longer drips but just fills the bottom part of the sponge could be seen as its mini water table. For us, this means that if you drill a well into an unconfined aquifer, the water level within that well will stabilize at the water table. This level is not static. It fluctuates with rainfall, evaporation, and groundwater pumping, acting like a dynamic underground lake surface. It is important to distinguish the water table in unconfined aquifers from the potentiometric surface in confined aquifers. While the water table represents the actual top of saturation open to the atmosphere, a potentiometric surface in a confined aquifer indicates the level to which water would rise in a well, which can be above the top of the aquifer itself. Another interesting detail is the capillary fringe, a thin zone just above the water table within the unsaturated zone, where water rises due to capillary action but is still under negative pressure. Understanding the water table is fundamental to assessing our precious groundwater resources. It directly influences well yields, the flow of water into rivers and lakes, and the availability of water for ecosystems. This dynamic boundary is more than just a line. It is a vital indicator of the health and sustainability of our hidden water systems beneath the surface.
If you love learning about water, like, subscribe, and keep exploring with us.